Hello folks, we are taking up the exercise 1.6. Earlier exercise 1.6 part 1 was over. Now we are going to the part 2. We have finished the question number 1, 2, 3, 4. Now it is to take up the maybe 2 problems or so in our next part. So this is our part 2 video. We are taking up the next question, question number 5. Let's go across the question. Question says that if x and y are two sets such that x has 40 elements and x union y has 60 elements and x intersection y has 10 elements, then how many elements does y have? So this is a bit new to us because we've been either finding out x union y or x intersection y. Now this is for the first time that we will be taking y as the number of elements in y. No problem, we already know the formula, so we are going to use the relevant formula and we are going to do our problem. So let's get right away with the problem. This is a part 2, and in this particular question what all is given, let's check. Given that they give us n of x, number of elements in x has 40 elements. They have told us that number of elements in x is 40. It's been given to us that number of elements in the union x union y is given as 60. They also tell us that the number of elements in the intersection is 10. N of x intersection y is 10. They ask us to find out the number of elements in y. So no problem, we'll use either of the formula, substitute and get the answer. So we can write, therefore, n of x union y for us is n of x plus n of y minus n of x intersection y. What we do is we substitute the values that we have and check how it comes. N of x union y for us is 60, n of x for us is 40, n of y for us don't know, n of x intersection y is 10. So in order to get n of y, let's keep this n of y here, take all the terms on the other side and try to see what the answer comes up like. N of y stays there and all these other terms are coming there. Plus 40 becomes minus 40, minus 10 becomes plus 10. So you have 60 minus 40, 20, 20 plus 10, 30. So the number of elements in y is 30. What have they asked us? They have asked us how many elements does y have. So you have to say that the number of elements in y is 30. That's how we'll conclude the answer. Quickly we go to the question number 6. Let's see what they say. In a group of 70 people, 37 like coffee, 52 like tea, and each person's like at least one of the two drinks. How many people like both coffee and tea? So it's more of the English that you should understand, and once you have understood the English in the question, you have to translate it into this mathematical language and to apply the formula, get the answer. It's only that much. Now suppose say if I am weak in English, okay, what should I do? If I am weak in English, I will catch hold of some words and I will try to use that word to get it converted into maths. For example, if I am weak in English, I will take care of the word both and I will make myself understand that both and will always mean intersection. Or I will look out for words like at least, either or. These kind of words generally indicate union. Now these are all generally, this more or less, that kind of a thing. It helps you to get across with the data and then apply the formula, get the answer. So these things, like kind of shortcuts, keep it in your mind so that it may be useful to you when we do the problems. So let us check now what happens here. We are with tea drinking and coffee drinking people. So I've told you that whenever you have such word problems, it's always you have to introduce. So you have to get across with these variables. So I mean with this set, you have to introduce a set. Generally we can introduce it as A, B, any alpha, any capital letter you can start with. But generally for convenience, whatever is given in the question, in our videos we will use it that way. It becomes easy. So because it is tea drinking and coffee drinking people, we'll take capital C and capital T. Okay, for the set. So let C, comma T indicate the set of coffee drinking and tea drinking people. Coffee, comma tea drinking people. So what happens? we have, let's check what is given there. Yeah, it says that in a group of 70 people, 37 like coffee. So it's N of C is getting, we could write here given. N of C, that is coffee drinking, that is 37. And then they say 52 like tea. So tea drinking, we know it's 52. N of T is 52. Then they say 70 people, each of them, they will like, see, out of the 70 people, though it is a total number of people, it has been told to you that at least one drink they will drink. So whenever they make such a statement, indirectly they are trying to tell you that the total itself is a union. Okay, so whenever they give you the total number of elements and they say that at least one of them, one of the drink will be taken by either of the people there, when such a statement is made, it indirectly says that the total is a union. So therefore, you can write N of C union T as 70. So that is also there. Now they have asked you for find the total number of how many people like both tea and coffee. So both means we have to find out the intersection. So therefore, N of C intersection T becomes by formula N of C plus N of T minus N of C intersection T. So what will happen? It comes to 37 plus 52 minus 70. 37 plus 52 means it's 9. 5 plus 3 it's 8 minus 70. So that will come to 9 here, sorry, 19. 19. So 19 of them like both tea and coffee. That's how many of them like both tea and coffee? Therefore, 19 people like both tea and coffee. We are supposed to conclude like this. So that is about the question number 5 and 6. We will be taking up the next two questions in our next part video. That will be our part 3. Thank you.